In this short video, I will present at a high level how ActiveScale cold storage works. ActiveScale now supports two classes of storage: a storage class for your active data based on hard drives, and a class of storage for your cold data based on tape. So how did Quantum implement cold storage? Well, ActiveScale now supports the S3 Glacier command set. This enables applications that support Glacier to take advantage of ActiveScale's cold storage class. And the S3 protocol defines how objects get written to ActiveScale's cold storage and how they are accessed. An object can be automatically transitioned to cold storage based on lifecycle policies. Objects can be put directly to cold storage, and to access an object that resides on cold storage, the S3 Glacier command restore is used. Now let's walk through how this works. First, we'll take a look at how objects transition to cold storage. In an ActiveScale system, you have some number of hard drives for your active data and some number of tapes for your cold data. And of the hard drive-based storage, some of that is allocated to existing objects and some of it is not. The amount of unallocated storage will vary from day to day as objects are being put to and deleted from that storage class. ActiveScale uses this unallocated space for staging and processing objects that are being transitioned to cold storage. Now let's say we have a lifecycle policy that says objects should be transitioned to cold storage after 6 months. Once the objects reach the age of 6 months, they are copied to the staging area and aggregated into containers. Even though these containerized objects are in a special state of transition, they are treated as if they are in the cold storage class, so they are accessible via the S3 Glacier command set, and they are erasure encoded to maintain ActiveScale's high durability standards. For efficiency, ActiveScale lets these containers get quite large. Depending on the object sizes, there can be hundreds of objects in a single container. Once the containers are safe and protected, the original objects can be removed from the standard class, storage space is recovered, and the container is written to tape. Sometimes you may wish to bypass lifecycle policies and put an object directly to ActiveScale's cold storage class. It's a very similar process. When an object is put directly to cold storage, ActiveScale will stage that object in its unallocated space. It won't immediately write that object to tape because, like in the previous example, we want to create containers for efficiency. So ActiveScale will hold on to an object and wait for more objects to come in or even transition. Once we get enough objects, ActiveScale will create the container, write the container to tape, and then do any cleanup that needs to be done. Now let's take a quick look at how objects are retrieved from tape. The Glacier command to do this is called restore, and it works like this. When a request to restore an object comes in, ActiveScale may not process that request immediately. And this is based entirely on the availability of resources such as tape drives. ActiveScale does, however, maintain a queue of restore requests. ActiveScale knows where these objects are. It knows what tape they're on and where on the tape they reside. So it will sort the restore queue in a way to minimize tape mounts and ensure objects are read from the tapes in a sequential, tape-friendly manner. When the objects are read from tape, they go back to the staging area. At this point, they are accessible to your S3 clients. Now, part of the restore command is a parameter that allows you to specify how long an object should remain in the staging area. You specify that duration in days, and when the duration is over, the objects are removed from the staging area. As an option, you may also choose to copy an object back to the standard class. It will then be treated like any other object in that storage class. So ActiveScale cold storage. This is Quantum's implementation of the Glacier feature set into ActiveScale. ActiveScale's cold storage uses Quantum tape libraries, and it uses unallocated hard drive storage for staging and processing to maximize efficiency when moving objects to and from tape. For more information on ActiveScale's storage classes, visit our website.